Today's lecture is associative property in binomial operation. We are able to have explained the binomial operations, and it has some properties. We have closure properties. We have commutative properties, and the word next is associative property. In our previous video, we are able to have done such video. You check our channel for the further maths class playlist. You will see all the explanations of the associative, the closures and commutative. But today we are going to the associative property in the binomial operation. But before we continue, don't forget to subscribe to these channels and share this video. So now today's topic is associative. What is the definition for the associative property? Given a non-empty set X which is closed under a binary operation, this is the operation, then we know that for every AB element of X, telling us that A operation B is an element of X. So, meaning that the value of A and B will be the non-empty set that has been defined. We now say that we can also combine the A operation B, which is the element of S, with another element of C to obtain A operation B operation C, which is the element of the non-empty set X. A non-empty set S which is closed under the binary operation. He now let us to know that is said to be associative if for every A, B, C element of S that A operation B operation C is equal to A operation bracket open B operation C. So if these two are now equal, it means the operation is associative. So now, we now have an example to explain all these the definitions of the associative property. Let's try to explain this example. The example telling us that it said, let X be a binary operation on the set R of real numbers defined by A operation B is equal to 2 bracket A plus B and bracket close. The question just said that is operation associative in R. So now we want to use this example to explain this associative property in a very way that you will surely get it clean and clear, that you're able to understand it better. So now, solution. So the first thing we are going to consider is said we have been given A operation B is equal to 2 onto A plus B. So this is the most important thing that we want to consider, because from this question, these are the what we have been given. So we have been given the operation, the definitions. We call A operation B as the definitions of the operation. This is what we are expecting to be operating on according to the definition. So in the application of binomial operation, we need to understand all this logic very well. So now we want to prove that A operation B operation C is equal to A operation B operation C. So now we are able to know the A operation B. Let's now combine it with operation C. So in combining with operation C, we have so now good. So let's combine with operation C, which now give us A operation B operation C. It now give us, it's telling us that in associative property, A operation B on its own, the whole answer is now turning to A. That's just the meaning. The whole answer is turning to A. So you said, which is this is the operation 2 onto big bracket. Now, A operation B is total of this, which is 2 onto A plus B. That is A. Now, plus B. Our B will now be C. plus C. That is just the meaning. So, therefore, because this is A, B, this is A, the A is this, C is this. So, and the definition is 2 brackets A plus B. So, let's try to expand and see what we are going to get. So, we have 2 on 2. So, let's try to expand. We have 2 times it, we have a 4 onto A plus B plus 2C. So this is the value for A operation B operation C. So now, we now need something like this again. A operation B operation C. So before we do this, let's firstly find the value of B operation C. In looking for the value of B operation C, recall that A operation B is 2 brackets A plus B. So now, A has turned to B and the B has turned to C. So this one will give us 2 onto B plus C. So now, this is the value for B operation C. So now, let's find the value of A operation B operation C. Now, recall that A has now turned to normal A, but B operation C has turned to B operation has turned to 2 onto B plus C. So we now have 2 from our definition. Recall, this is our definition, 2 brackets A. A is A already, plus B, and our B is B operation C. And what is B operation C? Which is 2 brackets B plus C, total bracket. So we have, so let 2 multiply, we have a 2A plus 4 onto B plus C. So now, this is A operation B, A operation bracket open, B operation C. Now recall that A operation B operation C is 4 onto A plus B. But here it is 4 onto B plus C. If you're able to combine the two together now, you discover that they are not equal. So therefore, the operation, it is not associative. So therefore, A operation B operation C, it is not equal to A operation B operation C. Since they are not equal, it's not telling us that the operation is not associative. So that is just the meaning. So it's telling us that this operation, it is not associative. So this is just the basic knowledge of associative property. These are just the basic knowledge. Now we are going to have another example now that will surely explain to us another forms of this associative, which will make you to understand it better and more. So let's try to go to the example 2 now. So this is example 2. In determines, he said, the operations on the set of real number is defined by x operation y is equal to 3xy. For every xy is an element of real number. So now to consider, to know, maybe it is associative, you need to prove a fact that x operation y operation z must be equal to x operation y operation z. So if these two, they are equal, now it means that it is associative. Now what is the first step we are going to do? Let's find, we have been given x operation y to be 3xy. Now we now need x operation y operation z. You know, recall that total of this operation will be equal to x. So we have 3 onto the whole value 3xy dot z. So that's just the meaning. This is x y. So this is x, y. So x operation y operation z will be 3 onto 3xy dot z. So therefore, x operation y operation z will give us 3 times 3, it will be 9xyz. So now, we also want to prove x operation y operation z. But the first thing we are going to prove is y operation z. And what is y operation z from the definition? This is the definition. So y operation z will be 3yz. Now, if y operation z is 3yz, so in now looking for x operation y operation z will be, recall, everything here will be z in the value, will be from the definition, everything here will be y. So now it will now be 3x dots. Now, y operation z give us 3yz. So which is 3 times 3, we have a 9xyz. Now, these are just the meaning. So you now recall that x operation y operation z is 9xyz, and at the same time, this is also 9xyz, telling us that x operation y operation z is equal to x operation y operation z. Since they are equal, it's now telling us that it is associative under the operation of the real number. So this operation is associative under the operation of real numbers. So that is just the meaning. So it's now telling us that it is associative under the operations of the real number. So this is just the best way of explaining associative property. So this is how to explain it in a normal form. So now I would like to give you a classwork. So this is the classwork. You are going to react to me in the comment section. Maybe you are getting it or not. So we now know what videos to do next. And don't forget to subscribe to this channel for a better values of education like this. So let's now stay for the classwork. So this is a classwork. It said the operations on the set of real number is defined by A operation B is equal to A plus B plus AB over 2. For every A, B element of real number is the operation associative. So do this and send your answer to me in the comment section, so for me to know what's next to do where you are. So and don't forget to subscribe to this channel.